So today we're going to look at factoring monomials. First, though, we're going to look at expanding, just so we get the correlation between expanding versus factoring. So this example here is a monomial times a binomial. We know that we now can use distribution to multiply 2x squared by 3x and 2x squared by 4. You end up getting 6x cubed minus 8x squared. That is expanded and simplified. There's no like terms or nothing else that we can combine. We've done the work. So if you're asked to expand and simplify, you leave it as a single polynomial. When we're going the other way, basically starting with a polynomial, and we want to put it into its factors, we would be given, and we're going to use the exact same example, and talk through the process on how to find the factors. So if we were given this polynomial, I was asked to factor it, to find the types of factors that you can remove from this. The first type of factoring we want to look for is always a monomial, something that takes, or that's divisible out of both two terms. So because we have two terms, we need to consider the coefficients and the variables of each term, and find something that divides out both of them equally. If we look at just the coefficients, our coefficients are 6 and 8. We're basically finding the greatest common factor between 6 and 8. It's guaranteed to divide both of them. 6 and 8 are both, in this case, divisible by 2. So that would be our numerical part of our monomial that would be removed as a factor. Then we need to consider our x cubed and x squared. The two terms have variables of the same base raised to different powers, but we need to find something that divides out both of them. In this case, x squared, the lowest degree, divides out both equally. You are left with a remainder for the x cubed, and x squared divided by x squared is just 1, but the greatest common factor that divides out both of these terms is x squared. So then, as a result, our greatest common factor for the entire polynomial is 2x squared. It divides out both terms, and we can move it out front as a factor that can then be multiplied by another binomial that will result in 6x cubed minus 8x squared. So you write your greatest common factor on the outside, and we need to figure out what's going to go in the brackets to make sure that they are an equivalent statement. So now we look at each term. 6x cubed. If I divide that by 2x squared, the 6 and the 2 will divide. That will give us 3. X cubed, x squared, when you're doing division on the same base, you subtract their exponents, so you get 3x. That would be your first term. Now I've got negative 8x squared. If I divide this by 2x squared, negative 8 divided by 2 will give us negative 4. X squared divided by x squared, 2 minus 2, is going to give us x to the 0. X to the 0 is the same thing as 1, so we can write it as negative 4, minus 4 in this case. As you can see, we get the exact same thing that we started with in the first example. Another example that we can work through, now I'm going to be giving you the polynomial, and I'm going to be asking you to factor it and to find the greatest common factor that you can remove. We have to look at all three terms now. In the last one we were working with a binomial, so we looked at 2 terms. Now we're looking at 3 terms. So if I look at each individual term, and we look at the parts again, if we look at the coefficients, 4, negative 6, and 2, we still want to find our greatest common factor. In this case of 4, negative 6, and 2, is going to be 2. Of your x cubed, your x to the 4, and your x squared, the greatest common factor of these 3, again, you need to find a power of x that divides out every single one. It works out to being the lowest degree. If you look at your y terms, y squared, y, and y to the 4th, the greatest common factor of those three variables would be y to the power of 1. So the overall greatest common factor is 2x squared y. Again, you write it outside as a factor, so it's going to become a product statement. 2x squared y now has to be multiplied by 3 terms, so that when I distribute it, I will get my 3 terms in my original polynomial. So again, we look at each part. The first term, 4x cubed y squared, if we divide this by our greatest common factor, the 4 and the 2 divides to give us 2. The x cubed and x squared, when you subtract their exponents, you're left with x. The y squared and the y, you're left with y. If we look at our second term, negative 6x to the 4 times by y, and we divide it out by the greatest common factor, we are left with negative 6 divided by 2 is minus, or negative 3. X to the 4th divided by x squared, 4 minus 2 is 2. Y divided by y becomes y to the 0, which becomes 1, which we don't need to write down. If we look at our final term, 2x squared y to the 4th, and we divide it by 2x squared y, 2 divided by 2 becomes 1. So we can say plus. You can put the 1 if you want, but you don't need to. X squared divided by x squared, again, is x to the 0. X to the 0 becomes 1. So now I've got 1 times 1. And y to the 4th divided by y becomes 4 minus 1, y cubed. This would be your factored form of taking out a greatest common factor of the original polynomial. You can always double check your work to make sure you've done it right by doing a quick distribution to make sure that it matches up with the original statement.